Today's lesson is exponential functions, graphs from equations without using a calculator. Okay, today's learning objective is I can graph exponential functions and their transformations by identifying the base and graphing three component key points first: x equals -1, x equals 0, and x equals 1, and then adding the transformations in the correct order by starting at the exponent. Let's take a minute and evaluate where we are on the learning spectrum from novice to expert. All right, let's start out with the exponential function is called a transcendental function, which means it is a non-algebraic function. Non-algebraic function. And this has to do with the variable is the exponent. So the function is in the form of a to the x, where a is greater than 0, and it is not equal to 1, and a represents the base. So I have when a is greater than 1, I have an exponential growth. When a is between 0 and 1, I have an exponential decay. Looking at the graph, whatever my point at 1 is tells me what my base is, and that's really important. Whatever my point is at 1, this is going to tell me my base. And it has to do whether I have an exponential growth or a decay. So let's just review some basics. The domain, which is all the values x can take on, are all real numbers. The range, all the values that y can be. As we see, I don't go below the x-axis, so the range is y is greater than 0. So that's telling me I have an asymptote on the x-axis. So an asymptote is a line that I approach that I do not go across. So my asymptote is at y equals 0, which is the x-axis. I do not have any x-intercepts. My y-intercept is at 0, 1 for the parent function. For my exponential growth, I am increasing, which tells me if I have a tangent line, I have a positive slope. And I am decreasing, which means for a tangent line, I have a negative slope. Is my function 1-to-1? Yes, that means the original function is a function and my inverse is a function. All right, let's do some examples. Okay, so I have the general form of a plus or minus a times the base raised to the power of b to the quantity x minus c plus d. Okay, so we've gone through transformations before. So I like to give myself some clues and say my horizontal transformation are backwards, and I like to draw them in red to remind me that. And my vertical transformations are normal, and I draw them in green to help me remind that. I need to do these in a specific order when I'm doing the transformations. I want to start up in the exponent, and I have them ordered here. And then I come back down, and I always am doing D, my vertical shift blast. All All right, I'm going to do one example, then I'm going to give you a chance to try. All right, graph the following transformation, f of x equals a to the x. Okay, so looking at my original function, I always want to identify what the parent function is and what the base is. So taking a look, I'm always looking at what is being raised. The exponents are raised to the base. So here's my base is 5 in this example. So the parent function for this equation is f of x equals 5 to the x. So I'm going to start and I'm going to graph 3 points for the parent function. So I want to graph -1, 0, and 1. X equals -1, 0, and 1. So I'm just substituting these into my parent function equation. So I think it's easiest to start with 1. So 5 to the 1 power is 5. 5 to the 0 power is 1. Anything raised to the 0 power is 1, except 0. And then 5 to the -1 power is really 1 over 5. So 1 over 5. So I want to notice that these two are reciprocals of each other. So that's really important. So I'm going to plot my parent function. I'm going to plot my 3 points. So I know I have -1 to the 1/5, 0 to the 1, and 1 to the 5. Okay, so I'm going to graph these. And I know I have a vertical asymptote on the x-axis. So I know I have, okay, so here's my parent function. So now I want to plot my transformations. So what are my transformations? So I start up in the exponent. So x minus 2, this is my C transformation. So I know when I'm subtracting, I'm going to the right. So my first transformation is 2 to the right. And then my second transformation here is a reflection. And this is a x-axis reflection. And I want to review the way I remember these is I know the x-axis reflection is first and the y-axis reflection is second. So I know they're in ABC order, just like x and y are in ABC order. That's part of how I sort those out and memorize those. Okay, so I have 2 transformations I am doing for this. So I'm going to take my 3 points and move them 2 to the right and then reflect them over the x-axis. So I'm going to take 2 to the right and then I'm going to reflect it over the x-axis. So 1, 2, and then I am 5 to the x-axis. So 1, 2, 3, 4, 5. Here I'm going to go 1, 2, and I'm 1 above, so I'm going 1 below. And I'm going to go 1, 2, and I'm at 1/5. So I still have my asymptote here, but now my equation is here. So this is my new equation. So now I want to answer my questions. What's the domain, range, and the asymptote? So my domain is all real numbers. I have no restrictions. I don't have a fraction. I don't have a radical with an even index. Range. So these are all the values that y can take on. And I can see my range is related to this horizontal asymptote. So I don't have any values above 0. So I know y is less than 0, and my asymptote is y equals 0. All right, I'm going to let you try the next one. I want you to pause the video, try it, and then see how did you do. Okay, so I'd start with the parent function. So my exponent is with this 2. So I know 2 is my base. So my parent function is f of x equals 2 to the x is my parent function. So -1, 0, and 1. So I'm substituting into my equation. 2 to the 1 is 2. 2 to the 0 is 1. And 2 to the -1 is 1/2. So I know these two are reciprocals of each other. All right, so let's look at what the transformations are. So I'm going to start up in the exponent. So I know this negative sign here is a y-axis reflection. And I know 3 here is d, my vertical shift. And I'm subtracting, so my vertical shift is down 2. Down 3. So I'm going down 3. All right, so let's plot the parent function first. So my parent function is I'm going to plot my 3 points, which are -1, 1/2, 0, 1, and 1, 2. I'll put in my asymptote. So here's my parent function. Now let's put my new function, my 2 transformations. So I'm going to take each point. First, I'm going to reflect it over the y-axis, and then I'm going to go down 3. So here's my first point. I'm going to reflect it over the y-axis. So I'm going to count 1. So I'm going 1 on the other side. And then I'm going to go down 2. So 1, 2. So my second point, I'm on the y-axis. So I'm just going down 2. 1, 2. And this point, my -1, 1/2 point, I'm going to go 1 to the y-axis, 1 more, and then I'm going to go down 1, 2. Okay. So my asymptote I don't think I went it far enough down. Hang on. My asymptote is at -3. Okay. So here we go. I got my new function like this. So one of the things I want to point out is whatever my vertical shift is, this is my asymptote. Okay, this is what my horizontal asymptote is. All right, so let's answer our questions about the domain, the range, and the asymptote. So my domain, I don't have a fraction or a radical with an even index, so I'm still all real numbers. My range, I can see I am just above the asymptote. So the asymptote is at y equals -3. So y has to be greater than -3, and my asymptote is at y equals -3. So I'm going to write down this is going to be at the D transformation. All right, I'm going to do another example for you. These have 3 transformations. The other 2 examples had just 2. So I'm starting out with, I want to identify the base and what the parent function is for the base. So 1/3 is what I have my exponent raised to. So I know 1/3 is my base. So my parent function for this is y equals f of x 1/3 to the x. I am still plotting my same 3 points, -1, 0, and 1. So if I plot 1/3 to the 1 power, that is 1/3. 1/3 to the 0 power is 1. So that makes 1/3 to the -1 power 3. So these are still reciprocals of each other. Okay, so I want to plot my 3 points. So -1, 3, 0, 1, and 1, 1/3, and 1, 1/3. So I'm going to plot these. So this one is a decay. So this one's my parent function. All right, so let's see what my transformations are. So I always start up in the exponent. So up in the exponent, here is my c value. So c is really -4. So since I'm going plus, that means I go to the left. So my first transformation is left 4. Next, I come down in front of the exponent. So this is my first. So this is my a value, which is a vertical stretch by 2. So vertical stretch by 2. So that means I want to take y times 2. So whatever y is times 2. So 3 times 2 is 6. 1 times 2 is 2. And 1/3 times 2 is 2/3. So I keep my x value the same, but my y values change. And then my third transformation is my D transformation, which means I want to do a vertical shift up 2. Okay, so we learned D is where my asymptote is. So I know that y equals D is my asymptote. And I put 0, and it should be 2. So some of these I find it's easier if you actually put the asymptote in first. And that really gets you started. Okay, so I'm going to take each point, I'm going to go left 4. I'm going to multiply the y value by 2 and then go up 2. So starting here, I'm going to go left 4. So 1, 2, 3, 4. So I am at negative, my y value is 3. So it says I'm going up to 6. So 1, 2, 3. So I'm going up to 6. And then I have to go up 2 more. So 1, 2. Okay, my next value, my value at 0, 1. I want to go left 4. 1, 2, 3, 4. I want to go up to 2, and then I'm going up 2 more. 1, 2. There's my second point. And then my third point here, I'm going to go left 4. So 1, 2, 3, 4. I'm going up to 2/3, and then up 2 more. So 1, 2. So I'm right here. Okay, so here is my new function. Okay, looking at that, my domain. I don't have a fraction or a radical with an even index. So my domain is all real numbers. My range is always related to my asymptote. So my asymptote is at 2, and I'm above 2, so that means y is greater than 2. All right, I'm going to let you try the last one. Oops. So I'm going to have you pause the video, take a minute to work it out, and then check how did you do. Okay, so I'm seeing that when I look at this, the exponent is raised to 4. So I know my base is 4. So I'm going to say my parent function is f of x equals 4 to the x is my parent function. So -1, 0, and 1. So if I substitute 4 to the 1, that's 4. 4 to the 0 is 1. 4 to the -1 is 1/4. So if I go plot my parent function first, I'm going to plot my 3 points. So -1, 1/4, 0, 1, and 1, 4. Okay. Now for my new function, I'm going to look at what my transformations are. So I'm going to rewrite this. This is not in the standard order. So I'm going to rewrite this as 4 to the -1 times x minus 4. I think that's a little bit easier to understand this way. So I start with the transformations up in the exponent. I want to do the y-axis reflection first. So this is a y-axis reflection. And then this is my c value. My c value is 4. And so I'm subtracting. I'm going 4 to the right. Oh, I wrote c. I went 4 to the right. So I'm going to take each point, reflect it over the y-axis, and then move to the right 4. Oh, I didn't write this here. Parent function. So I'm going to take each point and I'm going to reflect it over the y-axis. So here I'm reflected, and then I'm going to go to the right 4. So 1, 2, 3, 4. Oh, the other thing I want to put is my d value is 0. So I know my asymptote is at y equals 0. So d equals 0 here. So I know my asymptote is right here. All right, so my next point, I'm going to reflect over the y-axis. Well, since I'm on it, I don't have anywhere to go, and then I go 4 to the right. 1, 2, 3, 4. And my next point, I'm going to reflect over the y-axis and to the right 4. 1, 2, 3, 4. Okay. So my new equation looks like this. Okay, so answering my questions, what's my domain? Domain are all real numbers. My range is all the values y can be, and I am just above the asymptote, so that is y is greater than 0. Okay, that's it.